7226. Today's discussion will cover critical advancements in edge AI, from sustainable blockchain technologies to cybersecurity and federated learning. To start our event, I would like to introduce Dr. Javier Parra from EOTH, who will deliver the opening remarks. Dr. Parra, the floor is yours.
Thank you, Manal. Now I'll hand over to your moderator for today's event, Manal Jamal, who will guide us through the sessions and introduce our first speaker, Dr. Alain Pagani. Manal, thank you, and over to you.
Thank you, Para, for setting the stage for what promises you. Dr. Alain Pagani, Principal Research in Computer Vision at DFKI and the coordinator of the DH project. Dr. Pagani will give us an overview of the project's mission, objective, and its significant contributions to the fields of AI in DH.
So hello everyone, my name is Alain Pagani. I'm from DFKI, the German Research Center for Artificial Intelligence, and I'm the coordinator of the Network of Excellence DIH. It's my pleasure today to welcome all of you. I will give you a short presentation of the Network of Excellence itself for starting this session. So DIH is a network of excellence, on distributed AI at the edge. And we are actually a European project with 36 partners. So here you see the logos of all the partners. We are 14 partners who are research institutes, 10 universities, 9 industrial partners, 3 associations, and we come from 15 different countries in Europe. We have an overall budget of 14 million euros. We are actually part of the so-called AI Lighthouse. It's an initiative from Europe that creates a network of excellence on artificial intelligence. So actually, there are different network of excellence on AI. So actually, currently, we have 9 different network of excellence. DIH is one of them. And each of them is specialized in a certain aspect of AI, tailored for trustworthy AI, AI for media aspects, and so on. And DIH has the particularity to be specialized on edge devices and AI at the edge. So when we started the project 1 year ago, we have set 6 main objectives, and I will shortly present you these objectives now. The first one is to push forward the scientific excellence and the scientific progress on edge AI. For that, we are actually doing research on foundational aspects. We are looking at software, hardware aspects. We are looking at different ways of having hybrid approaches between edge and cloud. The second objective is to have a united community around edge AI, and for that we regrouped some of the best AI researchers in Europe and in the world. We try to push scientific excellence and to have a vibrant community. The third one is that we are actually preparing strategic research agendas with our specialists in writing different documents to help EU preparing a work program and an agenda for the future research. Then for the more practical things, we follow the concept of leading by demonstration. So we are not only providing agendas and reflections, but we are also developing technologies, and we are actually developing 3 use cases that I will present a little bit later. And we are looking at different aspects on technical things that we develop. Then we want to make what we develop available for the community. So we have different tools for this. First is a virtual innovation infrastructure. So we develop a virtual AI laboratory. But also we try to federate benchmarks and make them available for the community and datasets, testbeds. And the last one is that we want all of this to be also useful for the industry. So we developed a platform for making these things available and also marketable. So we have a AI on demand framework that is plugging into the AI on demand of Europe, and we have a virtual incubator. So what are the particularities of Edge AI, and why do we have a network of excellence on this? Well, we have identified very specific challenges for AI at the edge compared to AI in general. And we have a set of challenges we have to solve. The first one is more the methodology and software aspect. So since the AI is running on the device, so we would like to push on-device learning, on-device communication, and how to make all this data and the necessary software run on the different edge devices. The second is more linked to hardware infrastructure. So how are we going to follow the upcoming of new hardware? How are we going to integrate all this new hardware in an AI continuum from edge to cloud? How are we going to generate the code and tune and deploy all of this? The third one is the question on how do you make these tools available and easy to use for the community. So for that, we have the benchmarks, we have sharing of resources and a marketplace. Then the second set of challenges, of course, also the questions of security, privacy, fairness, reliability, and this takes a specific aspect in Edge AI. Also, how to establish this capability in Europe. So for that, we want to develop use cases in multiple domains and deploy also demonstrators. And the last one is how to make all these tools interoperable, because it comes with different challenges. For example, Edge AI will perform differently depending on the context, depending on the spatial localization, depending on the operational aspects and on the legislative aspects. So all of that are challenges that we try to solve. And we started to develop already tools to solve them. So the first one is the AI virtual lab, where different labs, different communities, different researchers can put their assets on a kind of shared market, and we can actually build up experiments by merging and making connect different parts. We also develop a marketplace in order to put these assets on the market, and an incubator for favoring the emergence of new companies. Now a little bit of the use cases. So we have actually 3 use cases that we follow in this project to show our technologies. The first is to use drones to monitor and inspect warehouse. So here, of course, there is a lot of Edge AI that is running in the drone. The second is using AI on satellite for satellite image pre-processing. So actually, it would be AI that runs actually on the satellite before the image is getting streamed to the Earth. And the last one is the concept of smart city, where we developed different tools for observing and helping pedestrians, but also cars, and to enhance security, all of this in the concept of smart city. So what we also do, since we are a network, a community, we organize different events. We started by the first event, which was the kickoff meeting last September in Kaiserslautern. Here you see the entire consortium, the representative of the different partners. But then we are also participating and co-organizing different conferences and workshops. So the first one was the Edge AI conference, which is actually mainly led by the project Edge AI. It was last year in October. DI Edge is a co-organizer of this conference. Then we also were present and presented different workshops in the HighPeak conference this year in January. So we had a conference on driving next-gen AI technologies, and the second on accelerated machine learning. We were also co-organizing the workshop AI Treats, which is the workshop on AI hardware test reliability and security. It was in May this year. There was also a common workshop or common event for all the network of excellence, which was the fourth community workshop that happened this year, end of June. And we had a nice presentation of the virtual lab infrastructure that we are developing. And now speaking about upcoming events, there is the next Edge AI conference that we are also co-organizing. It will happen in October this year, and there is still time for submitting papers. So the deadline is the 2nd of September. So if you are interested, please go on the website of the Edge AI conference and you will see the different indication to submit a paper. That's it for my presentation. And again, welcome here, and let's continue with the rest of the program.
Thank you, Alain, for this enlightful overview. It's clear that the age is driving innovation in crucial areas of AI.
So, yeah. Hello, everyone. Good morning. My name is Yolanda. I'm a project manager at Fundingbox, a consortium partner at the DIH project, where we are the responsibles of the management of the open call. Or in other words, we try to manage in the most fair possible way the selection procedure of the recipients of the financial support for third parties. During the AIH project life, we will run 3 open calls of 2 different types. The second and the third open call that will be very similar and will happen next year will be more focused on the industry. But the first open call that I intend to explain in detail today will be focused on the research. The AIH first open call for exchange programs will be open next Thursday, 29th of August, and it will be possible to apply for it until the 31st of October at 3 p.m. Brussels time. It's important to say that at that time, the system closes automatically, and it's no longer possible to click the submit button. And we are not able to include in the process any application that has not been submitted before the deadline. This open call is focused in researchers or PhD students that are specialized in AI at the edge. Applicants can apply in 2 different ways depending on their personal situation. They can apply as natural person or a single legal entity. We understand that natural person applies to freelancers or researchers that are not linked to any organization. And when the researcher is linked or has a working contract with a research and technology organization, an SME, and university, the legal beneficiary will be this organization, and this organization will delegate the researcher or the PhD student to perform the research. Natural persons have to be citizens or permanent residents in Europe or the associated countries, and the same applies to entities or organizations that have to be registered in one of these eligible countries. Well, what will these selected researchers or PhD students do? The exchange program will finance mobility and cost of living of these individuals to spend time in the AIH hosting institution, 5 months, and there they will perform common research in the field of AI at the edge that leads to significant advance. Ideally, and as a result of the program, a scientific publication will be produced between the researcher and the hosting institution. In this open call, we aim to select around 10 researchers to join the hosting institutions. The AIH open call has a maximum budget of 600,000 euros, and each beneficiary can receive a maximum amount up to 60,000 euros for participating in the exchange program. During the application process, applications must indicate the total required grant, and they will have to include a short schema or a summary of the budget of why they are asking for this amount. And well, later I will explain some examples of this. Well, which entities are the hosting institutions where the selected beneficiaries will be performing the research? We have 15 first-class organizations that are part of the AIH consortium and that have volunteered to host the researchers beneficiaries of the open call. We have first-class universities like Universidad de Castilla-La Mancha in Spain with their Visit Lab research group. We have the Sorbonne University in Paris with their French Centre National de la Recherche Scientifique. We have the HESO, the Applied Science University of Western Switzerland. That is the largest university in Switzerland for applied science. We have, sorry for my pronunciation, Bleking Institute of Technology, that is a prominent public university situated in southern Sweden. We have INSAID, the Institute for Computer Science from Sofia University. We also have University of Modena and Reggio Emilia in Italy with their IPERT laboratory for the Department of Physics, Informatics and Mathematics. We have the University of Glasgow in Scotland participating through the Glasgow Intelligent Computing Laboratory, and we have INRIA, that is the French National Institute for Research in Digital Science and Technology, and those are all universities. We have research and technology organizations like the Swiss Center for Electronics and Microtechnology. We have the FKI, that is Alliance Organization, that is one of the world's largest not-profit contract research institutes for software in the world. We have CETIC, Center de Excellence en Technologies de la Información et la Comunicación, located in Belgium. We have Ford, located in Crete, Greece, that is the Foundation for Research and Technology, HELAS. And we have Bicontech, the Visual Communication and Interaction Technology Center, located in San Sebastián in Spain. We also have a non-profit AI-focused association based in Switzerland, Bonsai's Community Association. And also we have a private company, Ubotica, located in Ireland, that builds space-ready hardware equipped with AI accelerators. So as you see, we have very varied organizations, and you will find all this information and details about them in the guide for applicants of this open call. And well, this takes us to the next part, where to find information about the open call. In the open call website that, well, you have here the link. At the red first tab, you can find the guide for applicants. That is the document where the legal basis of the open call is described, along with the selection process and all the evaluation criteria. In this website, you will also find the frequently asked questions document, and here you will find a collection of questions that usually arise when applying for the open call. And some other useful information, for example, some example of badges that you can use when filling the application form. The process for applying for the open call is quite simple. If you don't have an account in the Funding Box platform, you will need to create it, but the process is quite straightforward. Then you only need to click the apply button on the OpenCall website, at the OpenCall website, and start a new application. When starting your application, as you can see in this left side of the screen, you will see the different sections of the application form. All the ones that have a red star are mandatory, but well, we will really appreciate if you can fill also the statistical section, is good for us. And when you have filled all the mandatory sections, a submit button will appear on the bottom of the page. And after clicking it, you will see the application form as you can see it now in the right part of the screen. Here you can see how it looks like inside one of the sections of the application form. Again, mandatory questions have this red star, and at the top of the screen you will have a button to move to the other sections of the application. Here you have some helpful tips for the application. As said before, please remember to submit your application before the deadline. You can still modify it as many times as you need after submitting, so it's better to submit in advance and modify later if necessary. It's only allowed to apply once to this open call, so if more than one application from one applicant is detected, only the last one that has been modified will be considered for the evaluation. And now we go with what happens after the deadline, okay, the evaluation process. All submitted applications will go through a first check. Here the eligibility criteria is checked in all proposals. Proposals that not comply with the criteria established in the guide for applicants will be rejected. In the case of a high number of applications or some special needs of the project, the selection committee may decide to implement one evaluation step that is called in-out scope screening. Here, it will be checked if the scope of the proposals fit with the project scope, with the DIH scope, and proposals that do not fit with the scope will be rejected. Next steps will be the individual experts evaluations. And here each proposal will be evaluated by 3 DIH partner experts. These experts will score the sections of excellence, impact, and implementation. In the guide for applicants, you will find a detailed explanation about the process, the criteria, and the scoring system used for this evaluation, along with the thresholds that we have. As a result of this evaluation from the 3 experts, a ranking list will be produced. All proposals that reach the threshold or are above the threshold will pass to the next phase with this ranking list. Then, in the consensus meeting, that is the final step of the evaluation, the selection committee will decide based on the ranking list, the provisional list of beneficiaries and the reserve list. Normally, the highest ranked proposals will be selected for funding, but the selection committee might have some fair reasons for objecting a specific proposal, for example, the alignment with the goals and scope of the project, or the ability of the applicant to achieve the highest impact possible. Okay. Also, some ethical concerns or potential conflict of interest will be considered here. The selection committee can select proposals until the total budget of 600,000 euros is reached. And the exact number of proposals approved will be decided based on the overall quality of the proposals. if finally you are selected, you will receive a communication from our side asking to provide some documentation to perform the formal check. For example, if you are a natural person, asking for your national identity card to see that you are a citizen of one of the eligible countries. Only once your eligibility has been confirmed, following the formal check and the sub-grant agreement is signed by you and the DIH consortium, you will become an official beneficiary of the DIH program. And here you can see the planning for the exchange programs. The first stage, that is the plan phase with a duration of up to 2 months, will include the delivery of a research plan document created with by the beneficiary and his mentors at the hosting institution. And at the end of this stage, if all the objectives are fulfilled and approved by the selection committee, the beneficiary will receive the 25% of the grant. The second stage, that has as a minimal requirement a technical report on the conducted research, will last 5 months. These 5 months, the researcher has to be present at the hosting institution. During that time, the researcher should perform his research, and after fulfilling all the objectives of the stage, the beneficiary will receive the 75% of the requested grant. For the payment of the grant to be approved by the selection committee, the lump sum method is used. The lump sum is a simplified method of setting expenses in projects financed from Horizon Europe programs, and it means that the beneficiary or grantee is not required to present accounting documents like invoices, but is obliged to demonstrate that the implementation of the project is in line with the milestones set for it. Simply speaking, it means that the selection committee will assess the progress of the beneficiaries, the documents that they will deliver, and the quality of their work after the end of each stage of the program. And if the milestones are if the milestones and like deliverables, KPIs will be fixed in this research plan document that will be created at the beginning of the program. The selection committee will review and validate the evaluations and will make the final decisions and approve the payments or invite the beneficiaries of the projects who have not reached the threshold to leave the program. Okay. During the time the open call will be open, we will have a couple of webinars to help with the application process. Here you have the dates. All the information and registration will be available at the open call website, and here you have the links. And just for the info of everyone, here you have a summary of the other 2 open calls that we will launch next year by the DIH project. These open calls will be focused in solve some industrial challenges, of course, related with Edge AI, and I think that relate with the challenges that Alan was talking before about, the challenges of the DIH project. That will be defined by the DIH technical partners in the consortium. I think this is all from my side. I think that Manal has planned to have some questions now, so.
Firstly, thank you, Yolanda, for outlining this fantastic opportunity. And yes, as you mentioned, now the first question we received is as follows. I'm interested about this exchange program. I'm working as postdoctoral in the research background is related to deep learning models, specifically those that are to extract features from RGB captures in 3D informations, such as LiDAR or other devices. Currently, I'm working on simulation of a human-robot interaction in a warehouse environment using ESAC simulator to generate kinetic data. Within this topic, I have started to simulate an autonomous mobile robot in a human with several gestures to control it. Eventually, I will work on models to identify people and gestures by an AMR, and also creating a new scenario that both of them, MR and human, are cooperating in a task such as holding a table. Do you think my background and slash or my current expertise can be useful for some of the hosting institutions?
For sure, yes, but it will be on the applicant to check in which of these hosting institutions he will prefer, because in the application form, the applicants will need to select in which hosting institution they will prefer to perform the work, and also other ones that they will join if the first one they choose is not available. Okay, and in the guide for applicants, in the documents of the open call, they have information about these hosting institutions and their main lines of research, and also they can check more info available online.
Thank you. The next question says, when we want to write a proposal, should we provide a support advisor?
Sorry, should you provide a support advisor?
Exactly. This question is from Mahmoud Abbasin. I think he's also with us in live. If you have more questions, you can further explain it in chat.
Sorry, because maybe I don't understand well the concept of support advisor. You cannot be supported by a member of the consortium to write the application, okay? Members of the consortium cannot help in writing the application. Of course, if you are a PhD student in a university and you are supported by your advisor at the university, that is right, and you can also include collaborators in the application form to help you fill in it, but they have to be someone outside of the consortium to help you.
Okay, thank you again. Mahmoud is asking also, is there any specific template regarding the proposal?
Yeah, it's the application form. You will need to fill the questions that you have inside the application form. It's not, you don't have to send any documents, okay? You have to fill the information that is required there.
Thank you. The next question is, can I apply if I have received FTP grants from other projects before?
Yes, you can. In the formal check, it will be checked that there is not double funding. That means that you are not receiving money for the same project, but I think that will be not the case here because you will be performing new research now. Okay, so it doesn't matter if you have received FSTP before.
Thank you. Next one from YouTube chat is it possible to put up 2 or 3 parties big union for funding?
Sorry? Manal, sorry, can you
Again,
repeat? Because
it says, is it possible to put up 2 or 3 parties big union for funding?
not in this open call. This open call is for individual applicants. In the second and the third open call, it will be possible to apply as a consortium, for example, to SMEs or an SME with research and technology organization, but not in this open call. That is only for individual applicants.
Thank you. Pierre, if you have more further questions, you can add them in chat. Next questions is, do the PhDs have to focus on technical challenges only, or is the social aspect of collaborative AI also considered?
I think it's also considered. Yeah.
Okay. How research teams from small and medium businesses can join this call?
Yeah. You can apply as SME or a startup, and the SME or a startup will delegate one researcher from their team to join the hosting institution for 5 months. And the SME will be the one receiving the grant, and he will continue paying their employee, but the employee will be performing the research in the hosting institution.
Thank you. And the last one that we received from the description form says, does the exchange have to be 7 months continuously in a physical visit? For example, could it be 2 weeks physical plus 3 months remote plus 2 weeks physical plus 3 months remote, which give the total of 7 months?
In the guide for applicants, that is the legal basis of the open call, we say that the 5 months of exchange phase should be inside. And that only could change in a case of an emergency like pandemics or something like that. But if not, those 5 months should be inside. The 2 months of plan phase could be up to 2 months, 1 or 2 months could be done remotely. But the 5 months of exchange phase should be inside.
Thank you so much, Yolanda. If we don't receive any further questions, we're gonna take a short coffee break.
Okay, thanks so much, Manal. And for sure, if we have more questions, we are happy to receive them via email and try to solve them.
Yes, I will also highlight that there is a website that details the procedure, the QA questions. You can just check DH website, and you will find directly the link to the first open call. Thank you, Yolanda, for addressing those questions so comprehensively.
Thank you.
And now we will take a short coffee break. Please return by 10:25 when we will continue, where we will continue with our keynote addresses. We will dive into the technical part of the webinar. We will be addressing 3 key technologies: GreenBlockchain, cybersecurity, and federated learning and edge computing. See you shortly. Welcome back, everyone. Our first keynote address is on green blockchain, a crucial topic as we aim to merge technological advancement with sustainability. This session will be delivered by Miguel Gomez, a software engineer specialized in blockchain and DLT, a full-stack developer and an expert in sustainable technologies. Miguel, the floor is yours.
Hello, my name is Miguel, and I'm going to give a talk about green blockchains, okay? First of all, we are going to start giving some definitions. First of all, I want to say what is blockchain, okay? Blockchain is a decentralized and distributed data structure that stores information that is sequentially linked and cryptography secure in blocks. Each blocks contain a set of verified transactions and is added to the chain. in an immutable manner, ensuring transparency, integrity, and resistance to manipulation. This technology is used in some systems such as cryptocurrency, smart contracts, and other cases of distributed networks. The main parts of a blockchain, we can say that we have blocks, nodes, transactions, cryptography, distributed ledger, and consensus algorithm. Blocks. These are the fundamental parts of the units of the blockchain. Each block contains the transaction data or records, a header with the hash of the previous block, and unknowns. These blocks are connected sequentially. The nodes are the device or the computers that participate in the blockchain network. Nodes store a complete or partial copy of the blockchain, validate new transactions and blocks, and ensure the network is decentralized and resistant to attacks. Then the transactions are the part where information about the parties is involved. The amounts and the digital signatures that guarantees that the authenticity and integrity of the blockchain. The cryptography secures the blockchain through the encryption algorithm and protects data and transactions. Asymmetric cryptography with public and private key and hash functions are fundamentals to guarantee and secure the integrity of the blockchain and the network. And the distributed ledger, this is the fundamental principle of the blockchain, where each node and network stores the copy of the ledger. This distributed approach ensures transparency and decentralization. And the last, the consensus algorithm. What is really a consensus algorithm? A consensus algorithm in blockchain is a mechanism used to achieve agreement amongst the nodes participants of the centralized network on the state of the blockchain. Since the blockchain networks have no centralized authority, this is crucial that all nodes agree on what is the correct up-to-date version of the ledger in the blockchain. Consensus algorithm allow this to happen securely even in the presence of malicious nodes or network failures. I'm going to give a short definitions of the main consensus algorithm. First of all, we have the more famous proof of work, which is used on Bitcoin. Proof of work requires nodes to solve complex mathematical problems to validate new blocks. Nodes, or also known as miners, complete to find a solution. And the first to do that adds the block to the chain and receive a reward. Then we have proof of stake, in which the validators are selected to create new blocks based on the amount of cryptocurrency they own. Delegated proof of stake is another type of consensus algorithm and is a variation of proof of stake, where cryptocurrency holders elect delegates to validate the block of their behalf. Only a few nodes are selected to act as validators, which makes the process of validating blocks more efficient. Another type of algorithm is proof of authority, where there is a limited number of nodes which are authorized by their verification identity by a central authority. This is common in private blockchains or consortium blockchains. And then we have a really big family of consensus algorithm called Byzantine fault tolerance, which refers a set of protocols that allow nodes to research consensus, even if some of them they are malicious or malfunctioning. One of the most famous is Istanbul Byzantine fault tolerance, which is the one is in Hyperledger version. And what is really a green blockchain? Okay, green blockchain refers to blockchain technologies designed and operated with the focus on environmental sustainability, reducing the energy consumption and carbon emissions. And why this concept exists? Well, this is because proof of work, that is the main algorithm of some blockchains of Bitcoin mainly, it consumes a lot of energy. So this makes a lot of titulars and news talking about the consumption of proof of work. Okay, so when we have established these definitions, I want to start focusing on talking about Bitcoin and Ethereum, as they are the largest blockchains. These blockchains, throughout their existence, has been the two of the most noted in terms of the contamination due to their consensus algorithm, the proof of work. We are going to recapitulate the definition of proof of work to get a little bit of context. This is a consensus mechanism used in some blockchains to secure the network and validate transactions. This algorithm forces the network participants, that are known as miners, to perform a considerable amount of computational work in order to add the new block to the blockchain. Although Ethereum is one of the most pointed, Ethereum has now been able to migrate from proof of work consensus algorithm to proof of stake. This change was made in 2022 and was known as the merge. This change on Ethereum is a historical milestone that has managed to increase the Ethereum scalability and reduce its power consumption in 99.98%. However, Bitcoin still maintains the proof of work consensus algorithm, which is the main focus of the problem when we talk about power consumption in blockchain. But why is the main reason why Bitcoin hasn't done this change yet? Well, if we analyze the situation, we can deduce that there are the three main reasons why Bitcoin has not made the transfer from proof of work to other consensus algorithms that consume less. First of all, we have to say that Bitcoin has no developer foundation behind it, as Ethereum may have. Ethereum has the Ethereum Foundation behind it. This foundation allows to give a development direction to the network and speed the arrivals of update. In Bitcoins, since there is no foundation, the changes are made in the code, but they are really slow in compared with Ethereum. Another main reason is the philosophy behind the miners and people who support Bitcoin as a solution to today's society. Leads them to want support a very decentralized consensus algorithm like proof of work. And then we have a third point that, this is more theoretical, no like fact like the other two, and is that there is a theoretical assumption that the price of Bitcoin is tied to the mining price. For example, if mining a block of Bitcoin costs X amount of money, it is not going to make sense that mined Bitcoins are worth less than the mining price. Due to the characteristics of Bitcoin mining price, will always tend to go up, at least in terms of energy consumption. This makes that it is theoretically a scenario that in this theoretical scenario, if Bitcoin energy consumption go up, Bitcoin price will go up. But I think that, this is not mostly true, okay, or at least there are some solutions. So in this image, we can see two graphs. In the top one, we use to show the relationship between the mining price and the market price of Bitcoin. The yellow line represents the price of Bitcoin, and the blue one represents the mining price. The graphic that is in the bottom is used to represent when it's profitable to mine Bitcoin and when it's not. When the graphic below the line is above 1, I don't know if you can see here, this means that it's not profitable to mine Bitcoin. That is because it costs more money to spend electricity than the reward of getting it. While when it is below, it is profitable to mine Bitcoin. As we can see in this graph, leads us to think that there is a relationship, and this is true. But as I already said before, I think there are another solutions. Here we can see two graphs, okay? And we have to remind that Ethereum has passed from proof of work to proof of stake in a successful way. Ethereum Foundation has some mechanisms in proof of stake consensus that allow to successfully decouple the price of Ethereum from the mining price, as we can see in these charts. In the first graph, the one of Bitcoin, we can see just the price of Bitcoin, and the price line change the color from the Ethereum event of the merge. When it's red, it's because Bitcoin and Ethereum, they were proof of work. And when it's green, it means that Ethereum proof of stake has started. In the second graph, the chart represents the price of Ethereum, and the color of the line follows the same pattern as the first one. The red lines represent, as we already saw, the proof of work of Ethereum, and the green, the proof of stake. Although there is not enough data, and we still need to give more time, we can see that proof of work and proof of stake doesn't depend directly in the price. In this case, the merge has not been a problem for Ethereum. The price will not follow if the change of the merge were a problem, the price of Ethereum wouldn't follow the uptrend of Bitcoin during the last 2 years. And well, as a curious fact, when Ethereum was proof of work, it was really extremely profitable to mine Ethereum. To give you an idea, more or less every month, if everything went well, you got around 10% of the price of the mining rig. The mining rig were really simple to build for someone familiar with the world of computing, and they were simple a series of graphic cards in a chassis running 24 hours a day. Okay, so the relationship between the philosophy and the energy consumption, as we can see, in the long term, it seems that the decision of switching from proof of work to proof of stake is not going to be to accept the price in a negative way. So if the price is not the main reason of the change from proof of work for proof of stake, what is the main relationship between Bitcoin philosophy and consuming a lot of energy? Well, to do this and to really understand this question, we have to understand the context of creation of Bitcoin. Bitcoins appears in 2008, created by Satoshi Nakamoto in response to a global financial crisis, which the intention of creating a decentralizing and censorship-resistant financial system. The philosophy of Bitcoin has 3 main pillars that started to be created in the 80s and 90s by the movement of the cyberpunks. These three main pillars are decentralization, the absence of central authority to avoid manipulation, security, the network must be secure and resistant to attacks, and the last one, transparency and trust, achieving consensus without intermediaries. So to complete with these principles, Bitcoin use proof of work for as the consensus algorithm. This is the only algorithm that completes in the best way to these philosophy principles. These algorithms guarantee in the perfect way the 3 main pillars, as we mentioned, but the problem is that it's energy intensive. To understand the security of proof of work, any attack will require as much as computational power as the entire network, maintaining the integrity of the security of the system. Now we are going to start to do some comparisons, okay? And the first one is consensus algorithm under pollution, okay? So we already determined that the blockchain's pollution problem is centered in the energy consumption of the different consensus algorithm, especially on proof of work. Now, how much does it really consumes? Well, in the graph, we can see the comparisons, the comparative power consumption between proof of work of Bitcoin, the proof of work on Ethereum in 2022, and the Ethereum proof of stake consumption. As we can see, the consumption of the proof of work algorithm is the ratio compared with to the proof of work. We must understand that at the end of the day, the power consumption of proof of stake can be very similar to the consumption of web servers. Okay, while Bitcoin's proof of work consumes close to 149 terawatts hour, Ethereum proof algorithm in 2022 consumed 21 terawatts hour, and Ethereum's current proof of stake algorithm consumes 0.0026 terabytes hour. Actually, if we compare, we could say that Ethereum consumes 0.0017% of the energy respect the proof of work Bitcoin algorithm. Okay. Now, so as we already been able to observe through data, the real blockchain pollution problem resolves around proof of work algorithm and Bitcoin. How much does Bitcoin consensus algorithm consume? Well, we already said it, 124 terabytes hour. May sound like a lot, but what is really, what does it mean consuming all that energy? Actually, if we compare with the consumption of countries, it can become a bit alarming. We can see that Bitcoin right now consumes more energy than Argentina, Norway, Netherlands, or Portugal. It actually consumes much more energy than many countries in Europe. We are going to carry deeper in the investigation of the energy consumption by analyzing the origin of the energy. To do so, we are going to look in the origin of the energy consumption in terms of renewable and non-renewable energy in the European Union and Bitcoin. To correctly measure the consumption of energy of green energies in the countries, we will make into the account that we refer to the green energies consumed by the respect to the total energy consumed. Okay. So as we can see in these two graphs, Bitcoin has higher consumption of green energy than the average of the European countries. While 39% of Bitcoin energy's consumption comes from green energy, only the 22 of the total consumption of the European Union comes from green energy. Okay. Then another comparison to get more numbers. Well, to make the last comparison about countries and Bitcoin and put everything in context, in this graph we can see the top 10 green energy consumption of the countries of the European Union compared to the green energy consumption by Bitcoin. Ahead of Bitcoin, we find Sweden, Finland, Latvia, and Denmark. The rest of the countries have a lower green energy consumption than the Bitcoin blockchain. However, although this comparison may be worrying because the high consumption of Bitcoin, it makes little sense to compare the consumption of a network design at a global level, such as Bitcoin, with the consumption of a specific country. In a way, it will sound like comparing apples with pears. Okay, so for that, I'm going to get an idea of how much energy consumes Bitcoin. We will compare with other industries such as banking, global data centers, gold mining. Okay, so well, banking consumes close to 2,260 terabytes hour. Gold mining consumes 240 terabytes hour. Data centers consumes 460 terabytes hour, and Bitcoin consumes 149 terabytes hour. So we can see it's true that Bitcoin consumes a lot, but compared with other things, well, it is like in the range, to say in some way. Okay. So now, what challenge I think we can find on Bitcoin? Well, once we have already located that the problem, as we already said, is in proof of work and in Bitcoin because of his side. What paths could Bitcoin take to reduce energy consumption or at least reduce the carbon emission? Well, we have already talked about them. From my point of view, there are two main paths. One of them, and taking one side, it doesn't mean to rejecting the other path, okay? The first path is get Bitcoin miners to only use green energy. This only serves to gain time and avoid that the energy that they use don't pollute. In a direct way, since it will only pollute by the production technologies of the green energy. Actually, this option will not limit Bitcoin's energy consumption at any time. And in the future, Bitcoin will consume more. In short term, this is the most realistic option, and is the one that they are focusing on. At the moment, following this path, we can find different proposals making by the mining community. Some of them are the ones we find here, okay? And we have, the first of all is the Bitcoin Mining Council, that is a voluntary open forum of Bitcoin miners committed to the network and its core principles. They promote transparency, share-based practice, and educate the public on the benefits of Bitcoin and Bitcoin mining. The members of the Bitcoin Mining Council, they have three main principles, okay? Believing that transparency around the use of energy used for mining is important, and voluntarily sharing the mix of energy used and the size of the hash rate for educational and research purposes, sharing the best practice to other miners, and the last one is to promote the main principles of Bitcoin, which are decentralization, peer-to-peer, censorship resistance, and open source. Some of the foundation members of this forum, of the Bitcoin Mining Council, are Argo, Hive, and MicroStrategy. Then another one is the Crypto Climate Accord, which is the LEAF logo, okay? And well, the Crypto Climate Accord's overall objective is to decarbonize the global crypto industry by providing climate stewardships and supporting the entire crypto industry transaction to net zero greenhouse emissions by 2040. Some of the supporters of this accord are Consensus, Polygon, Near, and STX. And then, well, the last proposal of the community is Green Proof for Bitcoin. That is a pioneer interactive design to encourage sustainable Bitcoin mining. It improves a certification platform that evaluates and highlights miners that use renewable energy and contribute to grid stability through the use of low carbon energy sources on demand flexibly programs. Okay, and this forum or this project is supported mainly by Energy Web Token. Beyond this, it should be noticed that the technology is still advances, and more when we are referring to green energies. And we don't know if we are in the near future, we will get able to discover a way to achieve green energy that solves the carbon emission of energy production. If we could find a way of obtaining renewable energies very cheaply, efficiently, and with very little risk to humans, the process of this transaction will be accelerated. Then on the second path, we have to get in the consensus algorithm change to one that respects the Bitcoin philosophy, but still maintains the centralization, security, and transparency. This is the most complicated and complex path, not only because there is an organization behind Bitcoin, but also because the miners will have to be in favor of making this huge change. We also have to think that a lot of people and resources are taking into trying to change or think a way of getting a more efficient algorithm than proof of work, but there is the community hasn't found a way that respects the Bitcoin philosophy and at the same time don't use proof of work. Okay, but such fundamental change of changing the proof of work algorithm could be dangerous for the philosophy of Bitcoin, which is at the end of the day the reason why it exists. Okay. So the reasons why miners might not be in favor of this change is the first of all because of the philosophy. We have to understand that the miners are really conscious about society and they have a clearly vision of Bitcoin, so they don't want to make changes that would break these visions. And the other is the loss of their business and loss of money. Although the change of the consensus algorithm does not have to take a direct impact in the change, because you can introduce mechanism as Ethereum did to maintain the price, it's true that the miners, they are going to lose their business. And this already happened to the miners of Ethereum, that they stop their activity. Okay, so to finish with the conclusion, I want to take 3 main points, which are the proof of work conception is a problem and something that needs to be solved. In the future, if the things continue right now, the energy of Bitcoin consumed is going to be higher and higher, and we need to find a solution. Although this is a problem, we should not be alarmed by headlines such as we consider that it consumes more energy than Argentina. That's true, but we need to compare Bitcoin with its sector and take things into the ground. And the last main point, as we already said, we have 2 main paths, and is to change the consensus algorithm, or the more probably is make the energy used by Bitcoin mostly green. Okay, so that's all. And thank you for your time. I don't know if you have any question or anything. For my part, it's done.
Thank you, Miguel, for this fascinating insight into the role of blockchain in creating a more sustainable future. Our next keynote address will be focused on cybersecurity within DH. This session will be presented by Manuel Lopez Perez, who will explain one of the technologies that the DH project utilizes to secure AI at DH: security, orchestration, automation, and response. Manuel, the floor is yours. Thank you.
Hello to all of you. In this webinar, we are going to talk about SOAR. We will explain what it is, its importance, how it integrates with the rest of security tools, and what are the challenges we face to improve SOAR, using technologies such as AI. I am Manuel Lopez, Cybersecurity Analyst at the Yale Institute. In the presentation, you have my contact, and I hope you find this talk useful. SOAR means security, orchestration, automation, and response. The point of SOAR is to handle an incident end-to-end, automating before, during, and after the incident. It collects inputs monitored by the security operation teams, such as alerts from the SIEM system, threat intelligence platforms, and other security technologies, in order to help to define, to prioritize, and drive incident response activities. Orchestration in SOAR refers to the ability to integrate and coordinate different security tools and processes into an unified workflow. This allows the different security technologies to work together efficiently. Automation in SOAR involves the implementation of automatic scripts and processes to handle repetitive and low complexity tasks. This frees security analysts from that kind of monotonous task, allowing them to focus on more critical and complex activities. Finally, SOAR response refers to the ability to react quickly and automatically to security incidents, reducing response times and mitigation potential damage. The importance of SOAR in today's cybersecurity context cannot be underestimated. In a world where cyber threats are constantly evolving and becoming more sophisticated, organizations need advanced tools. SOAR helps to improve operational efficiency by reducing the response times and lightening the workloads of security teams. In addition, it allows for better incident management through the integration of different systems and automation processes. Implementing SOAR in our organization not only improves the ability to defend, but also optimize the use of resources, reduces cost, and minimize security risks. Now let's dive into the key components of SOAR, starting with security orchestration. Orchestration in SOAR refers to the ability to coordinate and manage different security incident tools and responses in an unified manner. In a typical cybersecurity environment, there are multiple tools and systems that work independently. SOAR allows these tools to be integrated into a single cohesive workflow. For example, when a security incident is detected, SOAR can automatically coordinate the collection of data from different sources, such as firewalls or IDS tools. Using predefined connectors, SOAR facilitates the communication between these tools, execution scripts that trigger coordinated response. This ensures that all security tools work together efficiently and without conflict, streamlining the process of identifying and mitigating threats. Automation, in short, focuses on the implementation of automatic scripts and processes that handle repetitive and low-complexity tasks. This includes actions such as collecting log data, preliminary analysis of alerts, and execution in initial mitigation actions. For example, when we detect an alert by our SIEM, SOAR can automate the analysis of the alert using correlated engines and machine learning to determine the veracity of the threat. Python scripts or playbooks in Jam can be used to execute predefined actions such as blocking a suspicious IP or sending a notification to the security analyst. By automation, this task SOAR significantly can reduce the manual workflow of security analysts, allowing them to focus on more complex incidents that require human intervention. In addition, automation helps to reduce response times, which is crucial in handling security incidents. Finally, incident response is a critical aspect in SOAR. Typical response processes that are automated include incident identification, threat containment, eradication of the malicious elements, and recovery of the affected systems. SOAR allows these processes to be managed efficiently and quickly. For example, when a threat is detected, SOAR can automatically isolate the affected systems using network scripts that segment and contain the threats. In addition, you can activate playbooks that perform malware removal using antivirus tools and restore systems from security backups. SOAR allows security teams to document every step of the response process in the incident management systems, making it easier to review and learn to improve future defenses. Documentation is done through automated records that capture all the actions, including timestamps and specific details of each intervention. Now, let's talk about the benefits of implementing SOAR in our organization, focusing on three main areas: improving operational efficiency, reducing the human error, and scalability and flexibility. One of the most significant benefits of implementing SOAR is the improvement in operational efficiency. In a cybersecurity environment, as you know, response time is crucial. SOAR significantly reduces the response times by automating repetitive tasks, as we said before. For example, the management of alerts generated by the ADS and the SIEMs can be automated. SOAR uses automated playbooks that, based on predefined rules, analyze these alerts, eliminates false positives, and prioritize the true threats. Not only does this reduce the manual workflow on an analyst, but it also allows for a faster and more effective response to actual incidents. The integration and coordination of different tools into a unified workflow also improves incident management, ensuring that all parts of the security system work together. Another key benefit of SOAR is the reduction of the human error. Automating critical and repetitive processes decreases the reliance on the human factor, especially under pressure, for example, in a crisis situation. SOAR minimizes the risk by automatically executing predefined action with precision. This includes applying security patches, blocking suspicious IP address, and running malware scans. In addition, automated documentation of all the actions taken during an incident allows for accurate auditing and facilitates the learning and continuous improvement. Scalability and flexibility are also very important benefits of SOAR. As cyber threat increases in volume and complexity, organizations may need systems that can scale and adapt. SOAR provides the ability to handle a growing number of threats without the need to increase the number of analysts. SOAR's ability to integrate new tools and technologies using some flexible connectors allows the organization to quickly adapt to emerging threats and change the defensive strategy as is needed. For example, if a new form of malware emerges, SOAR script and playbooks can be quickly updated to include new detection and mitigation techniques. This ensures that organizations are always prepared to face the latest threats. SIEM systems are tools designed to collect and analyze security data from various sources within an organization IT environment. They provide real-time and alerting on potential security incident by correlation logs and events. SIEMs help identifying threats and compliance issues by offering a centralized view of security-related information. They are essentially essential for threat detection, forensics analysis, and incident management. XDR is an advanced security solution that extends the capabilities of the traditional detection and response systems. It's like an evolution of EDRs and the antivirus. It is usually installed in the company's assets, analyzing data through these different layers of security, leading to faster and more effective response actions. Unlike SIEMs, which focuses primarily log data, these tools provide deeper integration and analysis across different security domains. SOAR platforms are designed to enhance security operation by automating repetitive tasks, as we said, orchestration workflows across different security tools, and managing incidents from detection to resolution. SOAR tools integrate with a wide range of security products, including SIEMs and XDRs, to streamline the incident response process. They allow security teams to respond more quickly and efficiently by automating responses and coordinating actions across the different systems and tools. SIEM, XDR, antivirus, and SOAR serve different purposes but can be complementary when they are integrated. SIEMs focuses on collecting and analyzing log data to identify potential threats. XDR extends this capability by providing a more comprehensive analysis across multiple security layers, improving detection and visibility. SOAR, on the other hand, is centered around automating and orchestrating the responses to detected threats, enhancing the efficiency of the security operations center. When they are integrated, these tools provide a powerful security solution. XDR can feed data into SIEM systems for more advanced correlation analysis, while SOAR can automate the responses actions based on the insight generated by both. Many commercial SIEMs now include SOAR capabilities. Now, let's discuss the challenges that we can face when implementing SOAR in an organization, focusing on two main areas: technical complexity and skilled staff requirements. One of the main challenges in SOAR implementation is technical complexity. Integrating various security tools and systems into a SOAR platform can be challenging or complicated. Each tool can have its own set of APIs, data formats, and communication protocols. For example, integrating a SIEM, firewall, intrusion detection systems, and malware analysis tools may require some extensive and custom configuration. In addition, the compatibility between these tools is not always perfect, which can result in interoperability issues. Creating automated playbooks and scripts that coordinate all these tools also requires in-depth technical knowledge and careful planning to ensure that all parts can work together. Another significant challenge is the need of trained staff. Implementing and maintaining SOAR solution requires cybersecurity experts with some skills. These professionals must not only have the deep understanding of security tools, but also understand how to configure and optimize them within a SOAR environment. For example, creating effective playbooks and writing automated scripts in languages such as Python may require advanced technical skills. In addition, security analysts must be able to interpret the results generated by SOAR and make informed decisions based on these results. Training and retaining staff with these skills can be challenging, especially in a field as competitive as cybersecurity. Organizations should invest in ongoing training and professional development to ensure that their staff is up to date with the latest trends and techniques in the cybersecurity. Below, we will explore some practical SOAR use cases, focusing on threat detection and response, integration with other security tools, and automating routine tasks. One of the most prominent use cases of SOAR is threat detection and response. Let's imagine a situation where an employee of our company clicks on a malicious link in a phishing email. The SIEM system detects unusual activity and generates an alert. SOAR springs into an action automatically, collecting relevant data from these sources, such as the firewall, the network access logs, and the IDS. Using this data, SOAR correlates events and confirms the presence of a threat. It then runs a predefined playbook that includes actions such as isolating the affected device from the network, initialization and malware scan on the device, and blocking the source IP from firewall. This process is done automatically and in a matter of minutes, minimizing the impact of the incident and reducing the response time. Integration with other security tools is another key aspect of SOAR. For example, in our organization that uses an EPS, a firewall, and SIEM, SOAR can act as an integrator that coordinates the actions of all these tools. When the IPS detects an intrusion, SOAR can receive an alert, query the SIEM for more information about the threat, and then update the firewall rules to block suspicious traffic. In addition, SOAR can generate a detailed report of the incidents, including all action taken and their effectiveness, which can be reviewed by the security team after. This integration and coordination between tools allows for a faster and more efficient response to threats, ensuring that all the security systems work together in a cohesive manner. Automating routine tasks is another significant benefit of SOAR. As I said, repetitive and low complexity tasks, which would normally require time and manual effort, can be automated to free up security analysts and allow them to focus on more critical incidents. For example, SOAR can automate the process of applying security patches when a vulnerability is detected by the system. SOAR can automatically download and install the necessary patch, verify the correct installation, and generate a compliance report. Another routine task that can be automated is the vulnerability scan. SOAR can schedule and run regular network vulnerability scans, analyze the results, and generate detailed reports of the vulnerabilities found, as well as recommendations for mitigation. This level of automatization not only improves the efficiency, but also ensures that safety-critical tasks are performed without the human errors. Let's talk about the configuration task in a SOAR tool. API configuration. Configure the application programming interfaces so the SOAR tool can communicate with other security tools such as SIEM, firewalls, IDS, and malware analysis platforms. Connectors. Implement specific connectors that facilitate the integration and flow of information between the different tools and SOAR platforms. Access credentials. Manage and secure access credentials for each integrated tool to ensure security communication. Let's see some example of playbooks. Basic playbooks. Create playbooks for a common task, such as responding to phishing alerts, vulnerability scans, and managing security patches. Custom playbooks. Develop playbooks specific to the organization's particular needs, such as responding to advanced persistent threats or mitigating some DDoS attacks. Test scenarios. Set up test scenarios to validate the playbooks are working correctly and that automated actions are executed as expected. About the configuration. Task automation. Define automated workflows for repetitive tasks such as collection log data, preliminary analysis of alerts, and generating reports. Response coordination. Establish workflows that coordinate incident response between different teams and tools, ensuring quick and efficient action. Let's see some real examples. For example, a playbook for phishing response. Step 1, receive and analyze the phishing alert from the SIEM. Step 2, collect information from the suspicious email, like the sender, the content, some links or attachments. The step 3, run link and attachment analysis using sandboxing tools. Step 4, isolate the compromised user account and force a password change. Step 5, block the sender's IP from the firewall. Step 6, notify the incident response team and generate a detailed report. Another example, another playbook for security patch management. Step 1, scan the network for vulnerabilities using scanning tools. Step 2, identify and prioritize systems that require patching. Step 3, download the necessary patches from the official repositories. Step 4, apply patches to affected systems during unscheduled maintenance windows. Step 5, verify the correct application of these patches and perform the functional test. And finally, step 6, generate and submit a compliance report to the security team. Another example, a playbook for malware detection. Step 1, receive a malware alert from the intrusion detection system, or the XDR. Isolate the affected device from the specific network to prevent the spread. Run a malware scan in the device using the XDR or antivirus tools. Step 4, remove the identified malware and perform a system cleanup. Restore the system from a backup if it's necessary. Step 6, update antivirus signatures and apply additional preventive measures. And step 7, document all actions taken and generate a detailed incident response. Okay, so in practice, let's talk about some tools. Security and events management, known as SIEMs, are systems that use technology to aggregate, analyze, and provide real-time monitoring of security events across an organization IT infrastructure. As I said, many commercial SIEMs in the market today include SOAR capabilities, enabling automated response and orchestration of security processes, enhancing overall threat management and incident response efficiency. In the market, most of SIEMs integrate SOAR. In the cybersecurity market, there are several SOAR tools that can be classified into two main categories: open source tools and commercial tools. Below are some of the most prominent in each category. Talking about the open source, first of all, the Hive, one of the most incident response tools, is an open source platform designed to manage and respond to cybersecurity incidents. It has a very good integration with MISP, Malware Information Sharing Platform, which is also open source, collaborative analysis, and uses a RESTful API. You have also Shuffle. Shuffle is an open source platform that enables the automation of security workflows through integration and a very visual playbooks. After we will see some examples. In the commercial part, we have Splunk, AVM, Palo Alto, Simplify, and most of the commercial SIEMs have SOAR capabilities. Let's see a SOAR environment using open source tools. For example, we can have the Hive as the security incident response platform. We can have NISP as the threat intelligence platform, and Shuffle as the SOAR platform. Shuffle bridges the gap between these components above and displays systems, application, and code. It provides a very good interface with workflow for automation of actions, responses, and scheduling of repetitive tasks. Also, you can see some ELK heads such as Logstash to ingest data from assets or Kibana for the visualization. Let's see an example of phishing analysis using the tool Shuffle. In this example, we are going to look for phishing emails. Shuffle checks if the samples have attachment and they are analyzed separately. Email is parsed with Python script that look for indicator of compromise. Also, we can use bias to talent equation. And if we detect anything, the findings will be sent to our notification channel. In this case, Microsoft teams. To create this workflow, we need to install Shuffle, then configure the workflow and the workflow nodes, configuring the email side from our server and the way to send notifications. With Shuffle, we can simply have to drag the nodes we are going to use and configure them. It's very easy. In this case, we have Outlook nodes, Virus Total, and Microsoft Teams for notifications. Now let's talk about the future of SOAR. The future of SOAR is very linked to the advance of artificial intelligence and machine learning. These technologies promise to transform the way we manage cybersecurity, taking them to new levels of efficiency and effectiveness. Below, we can explore how AI will influence the development of SOAR and the role it will play in the future of cybersecurity. Artificial intelligence can use large volumes of historical data to identify patterns and predict potential future threats. In the context of SOAR, this translates into the ability to even anticipate attacks before they occur or while they are occurring very quickly. Predictive models can analyze anomalous behaviors and flag them to potential risk, allowing us to take preventive rather than reactive measures. AI enables smarter and more precise automation. Instead of relying on predefined static rules, SOAR systems can learn and adapt to new threats and malicious behavior. For example, machine learning algorithms can improve automated playbooks, adjusting response based on the effectiveness and past cases seen in the past incidents. AI can provide adaptive and contextual responses to security incidents. Using natural language processing, SOAR systems can understand and analyze safety reports and alerts, providing an appropriate response to the specific situation. This allows the security teams to manage complex incidents faster and more accurately. One of the biggest challenges in cybersecurity is the number of false positives generated by threat detection tools. AI can help us improving the accuracy of the threat detection, reducing the number of false positives. Machine learning can filter alerts and highlight only those that pose real threats, reducing the workload on security analysts and enabling a more targeted response. The integration of AI into SOAR also enables to use real-time threat intelligence. Systems can access in real time to updated threat intelligence feeds and vulnerability databases. By combining this information with the real-time analytics, SOAR systems can proactively identify and mitigate emerging threats. The future of SOAR does not involve replacing human analysis, but rather enhancing their capabilities through human-machine collaboration. AI can take care of repetitive tasks and some preliminary analysis, allowing analysts to focus on static decision-making and complex problem-solving. This collaboration increases the efficiency and effectiveness of the security teams. The role of AI in SOAR is very important to the future of cybersecurity. The integration of predictive analysis, intelligent automation, adaptive response, false positive reduction, real-time threat intelligence, and human-machine collaboration will transform the way the organization deals with cyber threats. Okay, so as a conclusion, we have explored in detail what SOAR is, its key components, benefits, challenges, practical use cases, some examples, and the future of the artificial intelligence in its evolution. Let's reiterate some of the most important points. SOAR is a technology in the field of cybersecurity which integrates the orchestration, the process automation, and the incident response to improve the security management. For me, the key components are orchestration, that allows you to coordinate multiple security tools in a notified workflow, automation, that reduces the manual workflow and improves the operational efficiency. Incident response allows you to react quickly to threats, mitigating possible and potential damage. Some of the benefits of SOAR is that we can improve the operational efficiency, reducing the human error. and offers scalability and flexibility to handle a growing volume of threats. As a practical use case, this includes threat detection and response, integration with tools such as SIEM and firewalls, and automation of routine tasks such as patching and vulnerability scanning. Implementation challenges, these include the technical complexity of the integration of the various tools and the need of trained staff to configure and maintain SOAR solutions. So, looking ahead, SOAR technologies are positioned to evolve with technological advancement, especially in the following areas. Artificial intelligence and machine learning, as we said, these technologies will play a very important role in the evolution of all cybersecurity tools, especially in SOAR, enabling to predictive analytics, intelligence automation, and adaptive responses. Machine learning models will improve threat detection and reduce false positives. Advanced automation, as the artificial intelligence algorithms are becoming more sophisticated, SOAR systems will be able to automate more complex tasks and adapt to new threats without the human intervention. The integration of real-time intelligence sources, the incorporation of this kind of real-time threat intelligence will allow SOAR solutions to react in a proactive manner. In conclusion, SOAR is establishing itself as a very important tool in any organization environment. These kind of tools improve the efficiency and effectiveness of the security operations. With the continuous advancements of the artificial intelligence and other technologies, SOAR will continue to evolve, offering increasingly sophisticated and more robust solutions to face the cybersecurity threats on the future. So that's the end of my presentation. Thank you very much. I hope you found it interesting. You can contact me to see more examples or if you have any question. Thank you.
Thank you, Manuel, for those detailed insights into how security orchestration, automation, and response technologies is securing AI at the edge and ensuring robust protection for cloud and edge infrastructures. Our final keynote addresses will cover federated learning and edge computing towards a collaborative AI. This session will be delivered by Geray Mesquita, a postdoctoral senior researcher at the University of Salamanca. Geray, please take the stage.
Hello, everyone. I hope you can hear me. You're welcome to this presentation. I'm so happy to be here to share a little bit of my knowledge with you all. So first of all, I'm going to introduce myself. Let me know if this works. Yeah. Okay. Who am I? I am, as I said, a PhD computer. I hold a PhD in computer engineering from the University of Salamanca. Also, I am a professor at the International University of La Rioja. I am specialized in Industry 4.0, 4.0, and data analysis, and of course, natural language processing. So I have another task to do in the usual in the University of Salamanca as a machine learning engineer in the visitor research group. So, well, after seeing a little bit of background of me as a keynote in this session, I'm going to talk about the agenda for this presentation. Okay, first, because we are going to focus on federated learning and edge computing, we have to do a little bit of an introduction to both technologies. Okay, then after talking a little bit of them individually, we are going to try to put them together. Okay, we want to see what is the intersection between both technologies and what they can provide us. In that sense, in order to understand better what we can achieve with those technologies. We are going to we're going to describe in brief, of course. We don't have time to to go in deeper detail, but as a brief description, we are going to present some use cases of the intersection of both technologies. Okay, it will be three. I hope it is going to, all of them are going to be interesting to you all. All of them can complement a little bit of each other. It could be like how do I say it? Like aggregation, okay, an improvement, a next step, a next iteration of the process in each of one of them. So for different use cases, of course, but with a little bit of a twist between them. Then we'll talk about the benefits and challenges of the technologies and the use cases that have been proposed. And also we expose the future of these technologies and the conclusion to this presentation. So what is federated learning? Okay, first I want to provide a little bit of a definition. And not much visual. I will provide a little bit more detail in the next slide. But for now, we want to know that federated learning enables a training of a global model, of a model that can be used in a global scale, but trained in a decentralized way in local devices. Okay, so with this, each local device can hold their own data. They don't have the need to share the data to a central server that it is in traditional machine learning. Central server creates the model with an agglomeration of the different data sources. So in this case, we are going to just train locally a global model. Then those local models are going to be shared with a central server, and that central server is the one who will be able to aggregate those models without the knowing of the. Okay, there will be twists in the technology. It is not going to be that simple, but in order to keep it things simple, the central server is going to aggregate like an average, okay, of weights of the brains of the neural networks that are being trained in locally. Okay, so yeah, it's a iterative process. It is not going to do once. It is going to be doing in an iterative way. So after the local devices have new data, and after some time, then the global model is going to be retrained again. Okay, so as a brief history and evolution of the federated learning concept, it started in 2016 with Google. Okay, for the most common practice, the keyboard. Okay, the Google keyboard. It started with that because when you want to write and you want to use a keyboard in which you have some kind of AI behind it in order to suggest you what is your what will be your next word. You don't want your data. You don't want how you write, how you type in the keyboard, and much less what data you write in it. So, in that sense, Google created this concept in order for you, for your mobile phone, to train locally the algorithm, train locally the model for the prediction, and then aggregated it in a central server without the need of the data that you have used in your keyboard. Then no one is going to know what you type in it, what you write. So the breach potential of your privacy leaking, it's closed thanks to this concept. Okay, then after that, it evolved. Everyone saw the potential of this technology, and it evolved in other sectors like healthcare, industrial internet, or the automotive sector. Okay, so in this sense, as I mentioned, we are able to provide some privacy to the data distribution. Right? So thanks to the local training and a global aggregation. How does this technology how's this technology be implemented? Okay, we have a central server with a model. In the first iteration, the model will be an untrained model. It will be a model with random parameters. But then that model is going to be sent to the different devices, to the different actors that are going to take part in the in the training of the model. In this sense, each actor will take the untrained model or the model that the central server have provide them, and then they will create a local model trained by their local data without the need to send those data to the central server. In this sense, the model after the local training is sent again to the central server, and the central server, after receiving all the local models from the different devices, is going to average them. Is going to aggregate them. I said average because it is the most common, but there will be other techniques. Okay, we are not going to enter in detail on that. Then we will call this an iteration. After that, in a timely manner, after a few days, few weeks, few hours, it depends on the soul of our use case, we are going to send again from the central server the trained model to the local devices that will train it again, that will retrain it again. Of course, you can see here, there will be a little bit of problems with malicious actors, but we are not covering those problems right now. Okay. After this, I want to show you or introduce you, give you a brief introduction to what is edge computing. In this sense, edge computing, we can say that is the technology that refers to the processing of the data closer to the location where it will be needed. I mean, if we want the processing of data, for example, in a file, in a crop file, in which we have to take a lot of measures about the humidity, sun rays, temperature, I don't know, a lot of different sources, and we want to train. We want to make an action to that field, like activate or not activate irrigation, for example, or if it is a greenhouse, to open the windows for more ventilation or to provide more airflow, then we need that in that locally there could be a server, something like that. Okay, we can say a small server that will be able to process that information and provide an immediate action and fast action that will be in real time. In that sense, this is the opposite to what it is cloud computing. Okay, cloud computing, and we know it is so common. We all know what it is cloud computing, in which a central server in the cloud accessed through internet, makes the calculation, and then returns a response. Problem with that, latency. Okay, the central server will be faster in creating a response, yeah. But in order to create that response, the passerelle, okay, the small server that will be closer, that it will be inside our greenhouse, for example, has to send the petition to a central server. Then the server will have to compute the response, okay, much faster than the local server, but then it has to return it again. So in this sense, we are avoiding this intermediate time wastes, like the send of the petition and the reception of the petition, and then we can do it in a local manner. Of course, if we want to train a model or so, usually it is done in the cloud, and then the model is sent to the small device or the small server that will be able to use that model in order to provide a response. Bien. Okay, so after saying this, we have a little bit clearer what are the differences between the traditional cloud computing and the edge computing. So in this sense, we can highlight that in edge computing, we have local data processing. We can reduce the latency of the responses to take actions, and also we improve the bandwidth usage. In that sense, we don't need pioneer technologies in order to transmit the information, in order to send the information, because we don't use that much of a bandwidth in order to not taking action in a cloud and sending petitions every second, for example. Okay, in that sense, we can store information, and after a window time, we can send it back to the cloud server in order to improve or to retrain the model. Okay. So as a little bit of an explanation, I have here. Okay, I have here an architecture of a traditional edge computing use case. We have, in this sense, we have three layers: the cloud layer, edge layer, and device layer. The device layer is just the sensors and controllers. In this sense, we have sensors that take information and controllers that provide an action. Then in the edge layer, here we have the spiciness of this architecture. In this sense, we have a local network in which the sensors are going to connect to a passerelle, to a small server that will process the data, okay, will reduce the data used, will aggregate the data from different sources, for example, in the greenhouse that we did before. Also, we can control the responses for some kind of environment, some kind of change in environment or whatever reason. And also the virtualization of our for devices or use case or sensors, whatever. Okay. Then we have the cloud layer in which it is done the hard part, not the most important. I mean, everything is important, okay, but the hardest part in which it is not needed to use like in the edge layer that you are doing. We are able to give some kind of real-time responses. In the cloud layer, we delegate those tasks that can be done in a not real-time way, okay, in which the cloud server creates the model, makes that big data processing, creates data warehousing, trains the model, okay, creates the computing expensive parts of our use case, okay. So after this, we can say that those technologies could be combined in order to improve their efficiency, in order to improve the well things that they can provide. So how they can be complemented? In this sense, threaded learning can enhance data privacy, while edge computing can improve the efficiency of the platform. In this sense, once we are able to create a platform that can be trained in the edge without a need to share the data with a central server, we will be more prone to avoid attacks. All the attacks, of course, we know in this world, whenever you try to do something right, there will be others that are trying to do it wrong. So okay, but then also we can use it, for example, in the data processing. Okay. Also, we can use it. For example, edge computing, we can use it as a way to provide infrastructure for the decentralization that federated learning provides. So we are aware right now of the benefits of the use cases that they can be tackled. They can tackle. Okay. So how would be a combined architecture of federated learning and edge computing? In this sense, it is not far away from the architecture of a typical edge computing platform, but we can add the federated learning to these layers. As you remember in the previous image, we had the sensor layer, the edge layer, and the cloud layer. Is in the edge layer where the local aggregation, where the local training of the models are being done. Our passerelles, our edge servers, look, what they do is to aggregate the sources of information that are connected from the different sensors, IoT devices, for example. In this case, it would be the temperature sensor, it can be a car, it can be a mobile phone, a laptop, whatever. Then they will create a local model with those data. And then after creating that local model, it will send the model to the cloud server that will aggregate the different models received by the different edge servers in the edge layer. So how we do put this? How do we put this in use? First, we can provide an example of healthcare. You can imagine I extract this image, this architecture from this article. Okay, it's an DPA article paper. You can check it if you want to go deeper in the architecture. I'm going to provide a small explanation. Okay, a brief explanation of what they can do, or what they will be, or how we can relate the different parts that we have been talking about in the previous slides with a real use case scenario, like in this case in healthcare. In healthcare, for example, we have different hospitals. Those hospitals are going to have different machines that will provide, for example, in this use case, that will provide different images of radio diagnosis. In this sense, those images belong to the hospital and the patients that are connected to the hospital. Okay, so those patients are providing to the hospital with sensitive information about themselves. That information, we don't want that information to be shared with everyone. We don't want that information to be shared with different hospitals or different doctors that are not our doctors. We have to trust our doctors. We don't need to trust every doctor in the world. We don't want everyone to know about ourselves, to know our identity, or to be able to at least trace it back to ourselves. In that sense, each hospital, we have to trust a hospital. I mean, if you want a doctor to give you a diagnosis, you have to trust the doctor. So you have to provide information to him, her, or whatever. The thing is, the hospital can train their data. Okay, the hospital is going to train the data, and then the data is the trained model. Okay, after using your data, is going to be sent to a server that will aggregate it. Okay. The hospital is going to create neural network with artificial neural network with your local data, with the data you have provided, and then send it to the server. The server is going to aggregate the models sent by the different hospitals, and then it is going to be able to create a better and more complex model than if you use only the data of hospital web, for example. It's a no-brainer. Until now we know that the more data we can work with, the better will be our models usually. So in this sense, if we don't use all the data from the different hospitals, we can have some kind of bias, okay, once we create our local models. So in that sense, we can avoid that bias or improve the effects that improve or mitigate the effects of that bias by aggregating different models. Another use case we can see is in the industrial internet. Okay, in the industrial internet, we can have different robots. Okay, we can have different robots that are being controlled or that are doing some specific tasks. Those tasks are sent to the edge server. Okay, the edge servers. Those servers train with the data sent by those robots are being trained, and then using the cloud node, a cloud server, to aggregate those trained models. In that sense, then we can have two different processes. In this sense, in this use case, in the paper proposed, okay, you make uses of further learning with the edge devices and the cloud node, but then there is a little bit of a twist in which also we use, the authors use deep reinforcement learning in order to optimize the different tasks and actions that are being done by the robots. So it is very interesting how this is going forward. We can start to pile up different technologies, different ways in order to make to improve different processes and optimize those processes. So we are no longer just focusing only in the privacy of their users and the privacy of our robots that are the privacy of the robots, but the data that they are collecting from our company, okay? Our company or from the task we are giving them or are saying or are telling them to do. So yeah, it is amazing how this is evolving. In other use case, we will have a little more of a twist in which we also have the active learning technology. In this sense, we are having the typical edge computing and further learning architecture platform, in which here we will talk about the automotive sector, in which different cars are going to send information, and we will use that information in order to understand how they drive. If we can detect different plot holes in the road, for example, plot holes that perhaps today it's okay the road, but tomorrow there could be a plot hole, for whatever reason. But there could be, or a plot hole that today is not important, significant. It is small. Tomorrow could be a little bit bigger for, we don't know, because of rain, because of some kind of accident or whatever. Okay, so the first step in this sense is like what we've seen up to now. We have a central server that sends an untrained model to the cars. The cars generate data, and that data is used to train a local model. Okay, that local model is sent from the cars to the different receptors at a given time. Those receptors are able to aggregate the local model, those local models from the cars, and then create another local model again to the central server that will be aggregated again. In this central server, it is done another step in order to provide another iteration, another twist in our architecture. In this sense, provides the active learning loop that creates a data query. The data query label then the data received by the cars, okay? Then trains again with the labeled data and creates an estimation. After that, creates a secure aggregation of the different models with the received by the receptors that have been sent also by there will be data. Those receptors are parcels or edge servers in the architecture. And then we retrain again the aggregated model with a training pool of labeled data that we've done in the active learning step. After this, the updated model is sent again to the cars and the process is repeated again. So after seeing these two use cases, I mean, I'm sorry I cannot enter in deeper detail right now because of time, but we can say that there are three biggest improvements in this after using these use cases. After use the convergence of adaptive learning and edge computing. In this case, we enhance privacy and security for the users. I mean, not only because, like in the healthcare hospital, in which it is private data and sensible data for us, but also for our company in the other use cases. Okay. Also, we reduced latency. In this case, we don't need to go to a central server to provide a response, to an immediate response in our platforms. We can use our edge servers in order to provide a fast response. Finally, we can say that the usage or the bandwidth usage is more efficient than it was before. We just use the cloud, the internet, in order to provide with the models that we have created. We don't need to send data constantly. Okay. So what are the challenges right now? The most problem right now is the complexity of the implementation. Okay. We have to be aware that there are a lot of different devices, and those different devices don't always work well together. So we have to be aware of that. Also, we have to be aware that not all technologies are good in order to train different models, because even if we use local data, those local data can be big enough to shut down a small system. In that sense, we can also say that there are a lot of devices heterogeneity, that it is a little bit related with the previous challenge. In this sense, those devices sense data in different formats. Those devices perhaps are not well calibrated, or they have a little bit of a bias. It's one. So we have to be aware of those things. And finally, the data security and privacy, even though we don't share, or not always share, our data with a central server, there could be leaks in that. Okay, we have to be aware that we have to ensure that the data remains secure in our local devices. Okay. Also, after seeing these challenges, there are a lot of they have given birth to some strategies. In this sense, we can say that some technical solutions are the standardization of protocols for communication. We need the communication to be done in the same protocol for all of the parts of our system. Also, we have to create more efficient algorithms for model training and aggregation in order for the edge servers to be able to train a more complex model. with local data. And also we have to depend on the development of the regulatory frameworks, because the use of sensible data and the use of these algorithms and protocols will be challenging for our lawyers and our politicians in order to develop this kind of frameworks. Okay. Finally, we have to be aware that the data that it is shared from the sensors, laptops, mobile phones, etc., to our edge servers could be fished. I mean, could be sniffed and can be modified and attacked or stopped. So we have to use better practices for security and data management, like, for example, differential privacy. Another technique that it is being used already in further learning. So, what are the future? The future is, of course, goes by hand with evolution of technology. Better connectivity technologies like 5G is being integrated with our devices, so we can improve the efficiency of the communication between our edge servers and the central servers. Also, there are going advances in AI and machine learning algorithms. Those are the emerging trends that the scientific community are working more on it. Also, we expect improved hardware for edge devices, and the security measures and privacy preserving techniques are going to be given more twists with time being. Finally, I want to say that further learning allows decentralized model training. Also, edge computing, what allows us, what enables is the local data processing, and together they can enhance the privacy, reduce latency, and optimize the bandwidth usage of our platforms. So we have, after seeing this, we know that there are potential, at least there is potential to revolution the industry, the current industry, and because they are able to provide efficient and security and privacy preserving AI solution. So thank you very much for your attention, and let's see you later.
Thank you, Jirai, so much. In chat, we have two questions regarding federated learning and edge computing. And the first one is asked from Swiss Motive. And he's saying, hello, expert Jirai. Question, now whether is FL a patent model?
Let me check. What is the question?
If FL model is patent.
Yes, but I have to read the question. Let me open the because I don't have access to the. Let me check. Question now. Whether it's a patented model as per no. Patented. Okay, no. Federated learning is not a patented model. I mean, federated learning is a technology that it is an open technology. There are a lot of frameworks out there that provides to a platform to use this kind of architecture. So it is not a patented model. You can use whatever machine learning algorithm that for your use case is going to be relevant or not, in order to create these local models, and then it's just a, how do you say it? It's just a process. Okay, federated learning is just a process, while edge computing provides the how do I say it? The building of the platform. Okay.
Thank you. Thank you again. And there is another question, is which hardware systems or frameworks do you recommend to work with federated learning?
Okay. In this sense, I recommend Flower. I mean, there are a lot of frameworks I tried some of them, but the one I like it the most, and the one I've been able to create a pilot project in a how do I say it in a pilot in a project in a real use case scenario. It was Flower. From my experience, Flower is good. I mean, perhaps there are others that could be better, but for what I've worked with, Flower is the best one in this case. And hardware systems, we have used NVIDIA Jetsons for them, and they have provided enough resource computational strength for them to work with the local training to manage the local training of architectures or of our use cases. So
Thank you, Geray.
okay, thanks to you all. Thanks for the questions.
Thank you. We now move to our panel discussion titled Securing the Future, Innovation in Edge AI, Cybersecurity, and Green Blockchain. This session will bring together our expert speakers to discuss the convergence of these technologies, the challenges they present, and the opportunities they offer. The discussion will be moderated by Raúl López Blanco, a predoctoral researcher in BCT and part of the DH project, as a researcher also from University of Salamanca. Our panelists today, they are Miguel Gomez, Geray Mesquita, and Dr. Miguel de Prado, Technical Program Manager for European Project and Industrial Adoption at Verses AI, and Felipe Massonet, a scientific officer and coordinator at CETIC. Raúl, I will hand it over to you to lead the discussion. Thank you so much.
Okay, thank you so much, Manal. Thank you for the presentation. Welcome everyone to this panel discussion of the Edge. Today we are going to have very exciting discussions of emerging trends. Also, Manal presented the panelists, Philippe, Miguel, and Geray and Miguel that previously presented these keynotes. So interesting. Thank you so much for them, and for having time to discuss all the themes that we have in the table. We are going to start. I want to take a little introductory questions. Also first for Felipe and Miguel that was incorporated now to the meeting. For Miguel first, Miguel de Prado. Miguel, as partner of DH and project and leader of a smart warehouse use case, could you briefly introduce your involvement in the DH use case? A very brief introduction. Thank you.
Yes, of course. Thank you. Thanks a lot. So as part of the DIH, we're involved in two different use cases, the smart warehouse, as you said, and also the smart city. So for example, in the smart warehouse, we are looking to solve some challenges such as inspection and routing using autonomous systems. We'll be using, for example, drones and AMRs. And the idea is that we want to automate the inspection and detection of objects while we route efficiently some robots that move from A to B, for example. Since the warehouse is also a very dynamic environment with many moving elements, what we are trying to add is also uncertainty measurements into the system, so we can make the system more adaptable, so make them able to modify their behavior and also their route, for example, based on some elements that are very dynamic and inherent to the warehouse. For the other use case where we're also involved, which is the smart city, here is a little bit different. We're trying to connect automobiles and motorbikes with intelligent traffic lights and also crossroads, for example. And here the idea is that we can exchange information so that, for example, people in the cars or the motorbikes, they are aware of the environment, and also they have some sort of notion of where the pedestrians that might not be visible at the moment are, and also some anchors for direction of where I should go or things like this. And here this involves computer vision and also edge communication. And here latency is a very tight requirement in this case.
Okay, thank you so much. It's an interesting theme. Also for Philippe, for end these introductory questions. Philippe, you as a scientific coordinator of CETIC, and also I want to ask you for a very brief overview to the CETIC's role in the EdEdge and the main contribution to cybersecurity in the project.
Okay, so CETIC is leading the task on security, and I'll come back to that in a minute. But we're also contributing to the infrastructure. See, so the virtual lab where we're providing a gateway, an intelligent gateway that can link edge devices to more central services like cloud services. Coming back to the security, our contribution. So we're coordinating the task where there's a lot of work going on, and CETIC specifically is working on federated learning. Okay, so there's work on federated learning and work on securing federated learning, and that's what we're doing. We're looking at ways to secure federated learning, and this can be supported by SOAR techniques, because in federated learning you do model updates and things like that, and so you need SOAR techniques to do this in a secure manner. We're also doing a bit of threat modeling specific to edge AI. That's it.
Okay, thank you so much, Philippe. Okay, let's move on to the part of sustainability and green blockchain, the first keynote that we have in this morning. I want to ask Miguel Gomez to the context of managing AI resources, licensing, and how blockchain do improve the transparency and the security in this manage of AI resources. Miguel, you can do a very brief explanation of this.
Yes, okay. Well, blockchain can help this as it can help in other many fields, providing decentralization, immutability, security, and transparency. In the end, we have to approach blockchain as a layer that can be added in the different systems we have, seeking to optimize the qualities of the blockchain brings. In the context of AI, blockchain can play a crucial role in the traceability and transparency of the entire process, from the development to the implementation and monitoring of AI models. For example, blockchain can be used to trace all processes for explainability. Robustness can ensure that biases are avoided and that they are ethically formed. This is not only ensure that integrity, but also allows users and auditors to trace the origin of the data and know why algorithms and models have made some decisions, ensuring that ethical principles are made and avoiding biases. Although this may sound very far away, the blockchain already has some of these cases examples where, thanks to traceability and transparency, the ethical origin of a product can be ensured. One of the most significant examples is the one of blue diamonds. The blockchain has been used in this industry to trace every step of the process that diamonds go through, from the extraction to the final sale, allowing buyers to ensure that they are not financing unethical practice.
Okay, thank you, Miguel. Thank you so much for your vision of blockchain in sustainability and the green objective that we have also in this project. I want to move on to another block, more centered in federated learning and edge computing, and I will have in this block a question for the four of you. Now, we're going to examine the critical roles of the federated learning and the edge compute learning, enhancing the data privacy and security. I want to start with Geray. Geray, I leave you a minute to recover from your keynote. Geray, from your perspective, how does federated learning enhance the data privacy and the security of AI applications? Edge AI applications.
Okay. Feature learning can enhance the privacy of applications by first of all, don't share raw data. I mean, it is a little bit more complex than that. I don't think I will be able to explain it very well in right now. But the thing is, in order to use less surface for attacks, in order to provide less surface for different attacks, then the security is a little bit high level right now because of that. Just because you don't provide your raw data to a central server, you don't send those data in a communicating with a central server through internet. You are allowing less surface for attackers. You know, just because of that, it provides that a little that step on a securer, a more secure model platform. Also, we can say that about because I don't know how to say it, decentralization of the model training allows for the. I mean, if we only use the model or share only the weights of the model, we provide that step on privacy preservation. Okay, but also there are some mechanisms like I mentioned it in the presentation. Differential privacy. It's just a mechanism. It's a way in order to add some noise to the model. Okay, to avoid the attackers to infer from the model updates to gain information of those updates, you know, to get information of the data used to get those updates. Also, we have other techniques, you know, like for example, multiple parties, secure multi-party computation, okay, that allows different parties to compute over their inputs a function, okay, over their inputs while keeping those inputs private to keeping those inputs to themselves, okay. That can ensure that no one can learn, can know what other parties are doing, okay. So there are some mechanisms in this sense that can provide a step farther ahead about this information, the leakage of information.
Okay, thank you, Geray. Yeah, the leakage of information is an important part of the cybersecurity, but it's a small part of the cybersecurity. The big file of cybersecurity could also be a big part of this DIDH project, and maybe Philippe can throw more light on it, because what do you think, Philippe, about which other cybersecurity measures part of the data cipher and data privacy can we have in the federated learning process to ensure the edge privacy?
Yeah, so countermeasures are actually specific to the types of attacks that you want to mitigate. So the ones we've looked at CETIC, so where I work, are model poisoning attacks. Of course, where you inject false elements in the model, so it's making decisions that are not the optimal ones. Data poisoning attacks, so where the data is being corrupted, tampered with, at the origin when you do the local learning. Backdoor attacks, this is something we're really currently looking into. And privacy inference attacks. So these are the 4 types of attacks that we've been looking at. And in terms of countermeasures, we've been looking at anomaly detection. So doing this in a federated learning context, because this anomaly detection and then doing it for federated learning. And that allows you to counter model poisoning attacks, data poisoning attacks, and backdoor attacks. but not the privacy inference attacks. We've also been looking at differential privacy. So as was mentioned earlier by Uray, it's injecting a bit of noise in the data. So it's making your system a bit more resilient. But then, of course, you have to be sure that when you inject data, you're still accurate. Okay. And so this is a technique that can counter backdoor attacks and privacy inference attacks. We've also looked at security, multi-party computation, and homomorphic encryption. And this is a good countermeasure for privacy inference attacks. So homomorphic encryption, for those who don't know it too much, it's a technique where you can communicate encrypted data, you can process encrypted data. Of course, this has a high computation overhead, but it works in certain cases where you don't have too much data. So exactly when you're merging the parameters of the models in federated learning, in some cases it can work because you don't have that much data. And then a fourth countermeasure we've looked at is just encrypted communications, which is good against privacy inference attacks. So there are other countermeasures, but those are the main ones we have been looking at.
Okay, thank you so much, Philippe, for the response. Okay, in an ideal scenario in which we have resolved of these cybersecurity problems and we have no attackers, Miguel, how do you think that these technologies for data learning and edge computing that are now robust technologies could be used and are being used in the smart city warehouse and the other use cases in the edge?
Yeah, so I guess, as you said, this is the ideal scenario. So we're still experimenting with those ones and trying to adopt them. I believe the edge computing is more mature, so that's been more adopted. We see that these days already in robots that, for example, in the warehouse, we have the drones and robots that they can sense the environment directly. So that's edge computing. Smart cities as well. These days, all the cars are also providing some sort of computer vision analysis. So that's also edge computing. That's been more and more adopted, and I think it will evolve with AI a lot in the next years. Regarding federated learning, I think this is less mature at the moment, although there is some companies like Tesla that already provide these services where they aggregate data from different cars. I think in general it's less common. I believe that's one use case, for example, for automotive. But in the warehouse, it would be very interesting to provide communication between different warehouses of the same company, for example, in different countries, and aggregate data and knowledge from each of those ones without leaving the data, without the data leaving the actual warehouse. So it will be super useful in those cases for companies that, for example, work internationally. Although, as I said, this is still being developed and it's more on an experimental phase, I would say.
Okay, thank you so much, Miguel, for the response. Now let's move on. Let's move from another block. Now let's shift our focus on the smart city warehouse management. We will discuss the innovation and driving efficiency that's united with Miguel was exposing now. Particularly, I want to center in the IoT context and AI integration. Miguel, what is the best way to ensure the efficiency, to ensure the security of this warehouse management with IoT devices? We have IoT exposed devices like drones or other devices that are in a network, not network. We moved from this ideal scenario to a real scenario. We have these devices exposed.
Yeah, but I want to build on what Philippe said before. So it's several techniques that are being developed, like homomorphic encryption and many other security measures. So we try to work on those ones within this project, and I think we are at the front of research. For example, just to give some sort of scenarios where we see threats, we there could be some leak of data from those entities like robots or drones. Also the interception of communications when they're communicating some results and some sort of analysis from the robot to the central computing system, or even trying to disrupt or change a little bit the behavior of those elements. Imagine that there's a hacker that is able to access the drone and then basically could do whatever he wants with the drone, like crash it or do some other things that are not permitted. So what we are doing also, specifically also in this project, is we are developing some innovative protocols together with the IEEE standards that work at the edge. So these protocols are working at the edge and try to protect the communications and computation of these systems. And also what's very important, they provide a governance framework that try to ensure the security and privacy by design. So even though you may get access to those robots or drones, as it is built by design, these ones are not, for example, they wouldn't be able to access certain places of the warehouse where they don't have access to, because that's that's built into the protocols themselves. So these sort of different designs and algorithms that we're working on to try to protect these real scenarios.
Mm-hmm. Yeah, we are working on it together to have it in the project also in the future. Okay, thank you so much. Move on to cybersecurity and a smart city warehouse block. Okay, I want to ask for the question for Philippe. Because we've seen in the use cases that we need cybersecurity protocols. We hear it in the keynote too, the side of cybersecurity expert. We need SWOT techniques to have it controlled the cyber attacks. But I want to know to throw the question to Philippe. What are the cybersecurity threats in a smart city and the warehouse environments? Because in a smart city we have so many sensor and IoT devices that are compiling data and sending to a network or other centralized node. What are the addressing problems that we need to solve?
Okay, so we're in task 5.4. We're currently working on the requirements analysis and threat analysis to identify the threats in the case studies. For the moment, the smart city one, we don't have the analysis, so this is work that's ongoing. But based on the description of the case study, a number of threats and that are a bit typical of smart city environments are supply chain attacks. So supply chain attacks are when you do software updates, for example, in the cars, the red lights, or the whole infrastructure. If the update is corrupted, has been attacked, you're basically distributing malware in your smart city infrastructure. Okay, and this really happens, and a lot of attacks are supply chain attacks. So once you've done an update with a malicious software, backdoors are a very frequent attack. So you basically distributed backdoors a bit everywhere in your infrastructure, and then backdoors can be activated by attackers. And typically what they will do fault injection attacks. So for example, make you think that the red light, instead of being red, it's green. And so of course, you have disruption to traffic management. In the warehouse case study, the three main threats that have been identified are data leaks to external entities, and where the warehouse databases contain critical information about inventory, security protocols, operational procedures. So that's viewed as a threat. Interception of communications, which could lead to disruption of operations. This is the second one that's been identified. And the third, which is, I would say, maybe the most interesting, are disruptions to the autonomous vehicles, especially the drones, where you could have loss of control over the drones and unauthorized access to disruption to warehouse operations. So, for example, one attack on drones is if the drone is not protected enough or resilient enough, an attacker could make it take off when the battery is low, of course, leading to a potential crash and disruption of operations. Okay.
Thank you, Philip, for your expertise. Okay, let's move to the last block, future trends and collaborations. Okay. I want to ask all of you, I want to change a little bit the format to throw a question to all of you, and you can ask me with a brief response, okay? I like to ask you in your thoughts and in your expertise, the emerging trends in edge AI, in federated learning, and in blockchain technologies. What you think that are the most modern emerging trends, and what could revolutionize these fields? I don't want that you comment every files, okay? Only your expertise and the technologies that you are working on. But what do you think that are the most important technologies in the future? It can be start by Miguel. I think that is Miguel Gomez that is asked in a time.
Okay, so for the part of blockchain technologies, I think that one of the biggest efforts of changes currently being made in the ecosystem of blockchain is to seek as much interoperability as possible between the different blockchains that are based on Ethereum virtual machine. Also, a part of this, there is a big effort in general to look for consensus algorithm that can reduce transaction cost while respecting the economics within different chains. An example of this could be Ethereum, which 3 years ago, a transaction would cost around close to $100, and right now it's really rare to get a transaction over $5.
Okay, Yeray, your opinion?
Okay, from my point of view, I think in the intersection of edge computing, blockchain, and also federated learning, the decentralized edge markets, I think is a kind of platform that are being promoted much more, or from my experience, are being promoted a lot. So I will kind of have an eye on them. Also, in the these edge marketplaces comes hand by hand with the privacy preserving, federated learning, in which we are able to store in a private way some data, data of the models that are being created and so, and also the data that is being used to create the model, to train the model. But we cannot store it in the blockchain directly. We usually what we do is store it as a hash in order for us to know that the data is true, okay, is the one we want to use, or the one we have used in order to create the model, in order just to verify a posteriori. I mean, it's not something that we want to share with everyone. It's something that we want to share with specific agents, like, for example, auditors and so on.
Okay, thank you, Yeray. Philip, in your point of view?
I think that federated learning could be an important trend in the area of security. So I'm talking about using federated learning for security services. Okay, and I'll tell you why, because there's a lot of talk about how do you make the global infrastructure more resilient, more secure? And one of the obvious answers that comes from many different sources, and I'm not just talking about research, but government, a bit everywhere, is information sharing. And of course, the problem with sharing security information is basically you don't want to share it. Okay, so there's a kind of contradiction there. And this is where federated learning could be, come to the help, in the sense that you don't have to share the data, which you don't want to share, but you could be willing to share lessons learned in the form of models from the data. So, we'll see.
Okay, thank you so much. Miguel, your side?
Yes, thank you. So I will touch maybe on the edge computing. I think there's been a lot of progress on the cloud with ChatGPT and any other models. I believe that built a lot of hype that has not translated to real adoption by industry. I think people are starting to understand that it's very difficult to use these systems, specifically when you want to use them in your own instances and your own data, right? So I think that there will be a shift in understanding about AI and specifically how this AI moves to the edge. I think something that is very interesting is something called first principles algorithms. That means that it's algorithms that are grounded in physics, that they also have some sort of understanding of the environment and the world. And these ones are much more suitable for adaptation. So how mobile devices or anything that is at the edge can adapt to the environment where they're finally deployed, and not the training environment that's very static and just use some sort of data set that everyone uses. So I think this sort of dynamic algorithms or adaptable algorithms is something that will probably be the next breakthrough in AI.
Okay, thank you, Miguel, for the contribution. And my last question, a very brief words of you in the same order. I don't know if you have time to review it and consider it in the project, because we have only a year in the project, but we have the European AI on demand platform that is a base of research. It's an European project that has a load diffusion in Europe. But I don't know if you are going to integrate with this platform and going to use in the edge project, but it will play a very important role in the collaboration across Europe and our project, the edge. I want to know you little words to know your opinion and your importance in the project with this platform, with this AI on demand platform. In the same order, Miguel Gomez, do you see the platform and our integration in the project?
I think the platform is well done and is aiming really good with the principles of the European Union and the main principles of the technology. And yeah, I think it's really well done.
Perfect. Geray, by your side?
I mean, I am not an expert in how Europe is going to relate to the project right now, but what I've seen from other projects at least is that the European Union is putting a lot of effort in trying to deploy or trying to make use or rise more the use of explainable AI in order to avoid those models to be black boxes in which we just have an input and an output, and we don't know what's happening in between. That's why I think in the edge project, those could have an impact. Perhaps I'm mistaken myself, but from my point of view.
Okay, Philippe, by your side?
Yeah, so I believe that contributing to the European AI on demand platform is really important. With the work being done in the AI Edge with the virtual platform, virtual lab, But I think there's another dimension which I think is really crucial, and I don't know if we talk about it enough. It's access to data. I mean, as we all know, to develop good AI algorithms, you need a lot of data. You need a lot of specific data, high quality data. And so the issue of access to real data is really important. And so there's work at the European level on data spaces, which aims to basically solve issues of interoperability at the data level. So I think, I think there should be a stronger link between the AI on demand platform and the data spaces if you want it to be real, and work at scale.
Thank you. Miguel, last but not least.
Yes, sorry. Maybe what Philip said is very, very good. It's very interesting. I had already experience with the on-demand platform in previous European projects. I believe the current scope is discoverability. So you can discover data sets, models, algorithms, or solutions that are built at the European level. I think that's the first step. Going from discoverability to actual interoperability, there is probably a gap that we need to solve during the next years, so that we can reuse more and more data, or even like solutions, because it takes a lot of time and effort and money to build from scratch every time a solution, right? So that's a principal element or challenges that we need to address during this project, or the other projects that are in the European side, to address this interoperability between the different consortiums or different companies in Europe. Once we do that, I guess we'll be able to produce models and solutions much faster, and also with less effort as well.
Okay, thank you so much. Thank you all of you for all valuable contribution that you did it in this panel. Thank you for the assistance, and I think that we have a very valuable results of this webinar. Thank you so much, Manal. I return you the talk, and see you in another, and very, very soon in Eracle if you are going to be.
Thank you.
Thank you so much.
Thank you, Raul, and thanks to all our panelists for such an engaging and informative discussion. That brings us to the end of our webinar. A huge thank you to all our speakers, and again to our panelists for their time and valuable insights. I also want to extend my gratitude to each of you in the audience for your participation. Before we conclude, I encourage you to subscribe to our newsletter for further information and updates. We host many more events like this one, so be sure to check our website for upcoming events. Additionally, don't forget to subscribe to our YouTube channel, where you can find the recording of today's session and other valuable content. Thank you once again, and we look forward to see you at future DH events. Have a great day.
Thank you so much.